difference, and complement. So with illustrate sets using Venn diagram. Our first concept, union of sets. It's denoted by letter U. The set of elements that belongs to the set A or set B or both, or is denoted by A union B, or simply the union of elements of sets. Let's see here the map of the former Union of Soviet Socialist Republics, or simply USSR, which was composed of several countries. So with European Union, which is composed of various European countries. When we say union, it's another term for unite, merge, combine, or fuse. Let's have here our examples. Our set A, which contains square, circle, and heart, and our set B contains green heart, orange heart, and red heart. Let's take its union. A union B is equal to the set that contains, of course, the square, the circle, the violet heart, the green heart, the orange heart, and the red heart. Very good. This simply means union of elements of sets, set A and set B. Let's have another example. Same set A, but in set B, we added the violet heart. So now, same procedure, union of elements of set. The square, the circle, heart, and the green heart, the orange heart, the red heart, and also the violet heart. But wait, A union B is by definition is a set. So therefore, by definition of set, all elements should be distinct. So therefore, this violet heart here should be not included. So A union B is only these elements here. Next, if A is equal to the set that contains 1, 2, 3, 4, and 5, and B is the set that contains 6 and 7, what is A union B? Take note, union of elements of sets. A union B is equal to 1, 2, 3, 4, and 5. So with the elements of B, which is 6 and 7. How about if A is equal to the set that contains 1, 2, 3, 4, and 5, and B is the set that contains the elements 4, 5, and 6. Take note, again, A union B is simply the union of elements of set A and B. So A union B is equal to 1, 2, 3, 4, and 5. 1, 2, 3, 4, and 5. Since 4 is already on set A, we don't need to repeat it. So with number 5. Yet 6 is not on A, so we need to put it on the resulting union of sets. That's why A union B is equal to the set that contains 1, 2, 3, 4, 5, and 6. Very good. Next concept, intersection of sets, which is denoted by inverted U. The set of elements that belongs to set A and set B, simply denoted as A intersection B. Same as saying same elements of A and B. Let's look at this animation. These two roads here has an intersection. Same is true with these two lines here. When we say intersection, it is same as saying crossing point, joining point, or meeting point. Let's have here a simple example. Our set A, which contains these shapes, and our set B, which contains these shapes. What is the intersection of A and B? Or simply, what are the same elements of A and B? And it is the violet heart. Do we still have same elements of A and B? There's none anymore. Another example. If A is the set that contains 1, 2, 3, 4, and 5, and B contains 2, 4, and 6, what is the intersection of A and B? Same elements. The first element is 2 and the other one is 4. So therefore, A intersection B is the set that contains 2 and 4. Another example. If A contains 1, 2, 3, 4, 5, and B contains 6, 7, 8, 9, and 10, what is A intersection B? It is an empty set. That's because there's no same element of A and B. Next concept, set difference, or with notation, the minus sign. Set difference is the set of all elements of A except the elements of B, which is denoted as A minus B, or simply saying A take away all elements of B. Take note, A there is a set. Let's have here our previous set A, which contains square, circle, heart, minus set B, which contains circle, and heart. Therefore, A minus B, when we take away B from A, what is left is square. Very good. How about this example here? If B contains different colored heart shapes and A contains square, circle, and heart. Simply saying A, take away all elements of B. The problem here is only the violet heart is in A. So therefore, the answer is the square and the circle. Let's have another example. If A is equal to the set that contains 1, 2, 3, 4, and 5, and B contains 2 and 4, what is A minus B? If we take away 2 and 4 from 1, 2, 3, 4, and 5, what is left? 1, 3, and 5. Very good. Next example. If A is equal to the set that contains 1, 2, 3, 4, and 5, and B contains 1, 3, 5, and 7, what is A minus B? If we take away the elements of B from A, what's only the same from B to A is 1 and 3. And also 5. So therefore, what is left? 2 and 4. Very good. Let's have another example. If A is 1, 2, 3, 4, and 5 as its elements, and B contains 6, 7, 8, 9, and 10, what is A minus B? A take away all elements of B, but there is a problem here. There is no such element of B that is in A. So therefore, it is automatically the set A itself, which contains 1, 2, 3, 4, and 5. Very good. Next concept, set complement, or simply denoted as A prime or A complement. It is the set of all elements not in A but in U. or denoted as A complement or complement of A. And in other words, it is simply the universal set take away all the elements of A. Let's look at this example. If U contains the shapes here and our set A is the set that contains all heart shapes, what is A prime? A prime is actually all elements that is not in A. The square here and the circle. Next example. What if our U is equal to the set that contains 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10? And our set A contains 1, 3, 5, 7, and 9. So with B, contains 2, 3, 5, and 7. What is A prime? A prime or complement of A is all elements of the universal set not in A. What is left? 2, 4, 6, 8, and 10. Since A already contains 1, 3, 5, 7, and 9, we should not include it in A complement. How about B complement or B prime? Since B already contains 2, 3, 5, and 7, what is left is 1, 4, 6, 8, 9, and 10. Very good. So that's our 4 operations on set. Let's have now our exercise. Let's have our universal set that contains the elements 1, 2, 3, 4, 5, 6, 7 up to 15. And our A contains 1, 2, 3, 4, and 5. B contains 2, 4, and 6. C contains 3, 6, and 9. Set D is equal to the set of odd numbers from 1 to 10. E is equal to the set of even numbers from 1 to 10. And F is equal to prime numbers from 1 to 15. Let's have A union B. Take note, A is this one and B is this one. When we say union, combined elements of A and B. So, 1, 2, 3, 4, and 5. 1, 2, 3, 4, and 5. Since we already have here 2 and 4, we don't need to repeat it and we need to include 6. How about A intersection C? Same elements of A and C. What is our A here? What is our C here? So what are the same elements of A and C? It is only 3. Very good. How about intersection of A and B? We have here same elements 2 and 4. So therefore, A intersection B is the set that contains 2 and 4. What if we have something like this one? The quantity of A intersection B minus the set that contains 4. In operations of set something like this one, we need first to do the quantity inside the parentheses, which is A intersection B. What is A intersection B a while ago? 2 and 4. The set that contains 2 and 4. Minus the set that contains 4. What is left? It's only 2. D union E. D union E is the combination or the combined elements of D and E. Since D are the odd numbers from 1 to 10 and E are the even numbers from 1 to 10, therefore, D union E is simply 1, 2, 3, up to 10. Before we proceed, let's play Did You Know of Venn diagrams. Did you know sets can be represented using shapes? Universal set is drawn as rectangle and any set in U is drawn using circles inside the rectangle. In this case, set A and set B. Elements of set A is also drawn inside circle A, in this case, elements Y, Q, and H. So with set B that contains G, M, and R. This is also called Venn diagram. Venn diagram is the pictorial representation of sets. It is named after the great mathematician John Venn. Did you know sets with no same elements are disjoint? This means sets with no same elements are drawn separately. For our set A and set B, since none of the elements of the two sets are the same, then sets A and B should be drawn in two separated circles. Did you know sets with same elements overlap? This means sets with same elements should be drawn with overlapping regions. For our set X and set Z, since the two sets has similar elements R, then the overlapping region contains R. Overlapping of sets is best illustrated by total solar eclipse. Did you know there are also elements outside the set? In this case, elements outside the set is called set complement. Take note, consider only elements in the universal set U. Set complements is denoted by prime. In symbol, X prime. And in this case, X prime is equal to the set that contains M and G. That's because set X contains Q, Y, and R, and elements M and G are outside set X. Did you know there are also elements outside the set that is inside another set? In this case, our set X and set Z. Set X contains Q, Y, R, while Z contains A and G. And another element outside X and Z, which is B. Complement of set X or X prime contains B and also A and G. Very good. That's all for our lesson 1.3 and 1.4, operations on sets and Venn diagram. It has been a great day to all of us, as today we have learned something new. Again, I am Sir Jim, and this is Tele Mat Aralan.